Assalamu alaikum everyone. Welcome to another Dev Friday session. Today's topic is feature selection and principal component analysis. These two are uh, very crucial point whenever we want to data cleaning. So I hope you guys will enjoy this session. Today's agenda. In this session, my focus I will try to cover the feature selection, type of features, and code analysis. How do we use in or how do we select it, and finally we will see PCA. Let's start with first of all feature. So whenever we see the word, we think what is the feature? Well, feature is uh, simply if I say that it represent a column, okay, and then selection. So selection means we have a number of data, we have to select the perfect one. If we look in the picture that we have two design, so what we have one select, if we like this visual line we can select this, otherwise we can this. So selection means this give the sense it. So why do we need of feature selection? Well, the answer is simple. Our goal is to increase the model performance and reduce the overfitting. So during the training model, if we have uh, irrelevant features, it might be reduce the model performance. And uh, if we have a lots of irrelevant data included in our data set, then definitely our model cannot perform well. And we want to reduce overfitting. Another important topic is we all know that overfitting means the data well fitted the train, but when we give the unseen data it cannot give the as like output like the training. For example, during the training data we got 100% or 90%, 95%, but when we give an unseen data the model returns 60%, 70%. So the type of feature selection, there are commonly used three method. One is filter, another is wrapper, and another is embodied method. There is also a debate exists that there are many way we can do this. So I am talking will talking about these three things: filter and wrapper. uh, I will say example in my notepad, but now I will give a brief description. Filter methods select data based on their statistical properties, such as correlation or information gain, and in so many way. In the wrapper method, feature selection uh, based on performance about subset of feature. So I think we have an you have an idea about subset. And the dimensional reduction, that is our the last part of this session. um, so feature selection and dimension reduction, there is different. In dimension reduction we want to the 2D, for example, in our data has two feature. When we visualize it in the scatter plot we can see the 2D visualization, so we want to convert it 1D. So this is not the big deal, but whenever we have 150 or 60 dimensional, can you visualize this image? No, there is no way we can visualize more than 3 dimensional. 3 dimensional sometimes is not possible. So that's the way we can reduce the dimension. And it's help to visualize us. So there are many way, as I already told it, that a code we can do many way, what we have lab or what we want to do. So definitely there has a lot of advantage, but for the beginner, I am considering principal component analysis, that is too famous. So what it do, we will see in our notebook. Okay, now I am going to my notebook. Okay, so first of all, I will talk about filter method. Okay, so for example, I have an experience feature and another is salary feature. So if the experience is 1 year, I consider that he per year he income 10 lakh, 2 15, 3 25. So we can easily say or predict that if the experience is rise, the number of salary increase. This is relevant. Okay, so we have no problem about this, and we all know the grand truth about it. But what if I say that there is an extra feature in my data set? There have a lot of features, so we can blame or others it. Don't know what is happening. No one's okay. Well, forget it. So if I say that if his height is 7 inches, it can be 10 lakh 5, or I give that 9. That is impossible, but I will tell him. So let's see. I have another feature, uh, 5.5, and his experience is 4 years. We can tell him he give 30 lakh. So there is no relation that if the height is high, he can give high salary. If the height is low, he can low salary, or low vice versa. But in our real scenario, look at the job industry market, that there is no job sector which calculate the height. So in this case, the height is irrelevant for this salary prediction. So what it help, it affect the performance, it reduce the performance also. So what we have to do before training, according to the filter method, we have to filter it and we have to discard it. So okay, I know this is the common example, that's why I can say that height is not relevant with salary. So what if I have like 20 features that I don't know? For example, I giving that A, B, C, D, and the target value is E. Okay, and data is so on. So we have 20 features and one target value. Let's say our data is 1000 into 21. We know this represent the number of column. Number of column means feature, and the last one is target value. So that is why we find 20 features. Okay, so I have 20 features. How do I know that which one has most priority among the 21, or I want to consider the top 5? So how do I calculate if I randomly select this or this or this? So should I give the best answer? Maybe or maybe not, but there is a big possibility that I will not find it. Okay, so what I have to do now, for this I have to calculate each feature with the target variable feature 1 target variable, feature 2 target variable, and find the this is the target, find their performance or correlation. What I have to like to do, I can do this. So I find their correlation, and based on this I will find different value. So among them I will sort it, and I pick the top 5 or top 10, whatever I want to keep. So this is the one way we can filter our data. So another method is wrapper method. Wrapping, I remember the term like wrapping to wrapper. Okay, so it has two types, forward and another one is backward. So what happened in forward, if we consider one thing that is easily understand, we can also the backward. So forward selection, all model goes to inside an ML model, and then it's return and update performance value or accuracy, and after that it give me like and a rank associate with value, and then I will select the subset of it. Okay, for example I have 4 features. Okay, so we know that the subset is the combination of AB, or we can say the ABC, A, C, D. This is the subset. Or how many subset we will find the unique subset to the power n, and if we discard one, the main one, so this answer 15 combination we will find here, and then we will select one. So firstly what it do, it can goes to any method. Okay, I want to tell one thing about that. In the filter method we do before training, but it can also during the training time we can do. It can go to the ML model, first of all A, and we can find some value of A, and then go to B, we also find it some performance, and also we can see here ML model, we can also find this is B, A, C. So now I want to rank. For example, I want to rank this. According to rank, I so write this. So what I have to keep? I can I keep A, B, or can I see A, C? So depend on how do we select in the forward selection. So this forward came here from the features came into the uh, drive into the ML model, and it's return the output. There is no back way. So in backward elimination, all what it have to, it iteratively, as the backward, it iteratively removes one feature at a time. For example, first this is not much relevant, it discard it. Okay, I had another one. Then another iteration, it can see that this is not also related to the data. So this is the way it can works. So now our feature selection, our third topic. Okay, so embedded features, what it do, it is the combination of filter method and wrapper method. So we all know that the lasso L1 regression is the part of embedded feature selection. So So far what we have to know, that feature selection means we can reduce some features, we cut the irrelevant feature from our model. As a result, we will improve our performance. And before I dive into, okay, I see how the actual code is work. I use Kaggle here, so I can have a data set. Just wait a minute, it load, it takes sometimes. So I know you have enough idea about Kaggle, how, why I chose Kaggle over to Google Colab. I love using Kaggle, that's why I am selecting it over the Google Colab. Also, you know that the Kaggle is uh, Google product, so that's the update version, and I look like this. So editor is loading. Sometimes it take some time, depend on the internet connectivity and the others thing. Okay, before the loading it, I want to share that features dimensional reduce means what does it. Okay, I will talk about something about PCA. What does PCA do and why feature selection? In feature selection we remove feature, but in the dimensional reduction it doesn't reduce feature, rather than it reduce the dimensionality. For example, we consider this is two dimensional, and uh, this is considered as a three-dimensional figure. Sorry, I am not good at in the enough drawing, but I try my best to draw. So this is the upper face and this is the, but what have, if someone says or some data had 50D, how do you visualize it? Is there any way? So by PCA we do that 50D to 1D or 2D, as we can easily visualize it. Okay, okay. So in the PCA there has a lot of mathematical competition, so I'm not going here. What happened, man? It's take so many time. Don't worry, I will share this code with you guys, but I don't know what is going behind on it. Sometimes this feel boring, make us when it's not loading. Okay, I open another tab and I see what's going on actually. Okay, so if you like this you can boot here. Okay, there is a competition. I see that which one is taking first place. Come on, man. Okay, finally it's come. So bad for man. Okay, so I have a input data set which is mobile price. So here we can see that, don't worry, I will share the code, you will find in the description. So what I have to do, first of all I run this code. So this is by default written by Google Colab. So it's written the what is our input file or what is our associate output file. So it also take a few minutes, as we can see that draft session booting the kernel. So we have to wait a minute. Yeah, our progress is start. So the green mark is alert, it means that we can dive into our code. Okay, so this is the PD means panda library. We can read the csv file. Where you find the csv file? The csv file is here. And how do I find it? I find through this path. Okay, I want to know the shape of my data set. Okay, so could you know why it give me error? The error comes from that I did not run this code. Okay, so now I see that it has 21 column means feature. So I want to keep the last one is for our target variables, and I see that how is the data set. Okay, so if I give the head, I see that the last value price range between categorical. So easily I can say that this is a category range 1, range 2. So based on this feature, which price range category in the mobile. Okay, so this is the way I can extract the feature and label through this code. So I lock return the index. I know you have the much idea about it. So after the extract it, what I have got, the shape of x is 20, that we discard the feature target variable, and the y shape is 1. So 1 there is not here. And if you want to see the value of y, so this is index number, so don't be confused. This is the y category. So our category is depend on 0 to 3. If you have doubt that number unique, so how much unique variable in the okay, for typo mistake. So we can see that there are the 4 category 0 to 3. Okay, so after reduce the price range, how what will be there, then we can see that the last value is Wi-Fi. If we give move the previous one, we can see that there is the price range and the last value. So I select k based. This is also the feature selection method, and what I have to do, that I initialize the model and I train the uh, feature. So what I will find and array, it's return that the correlation between the target variable and the score. So okay, I have to go here. I can see that features and score in a way. So what I have to see here, I can see that the battery power, load, dual sim, mobile and RAM. So this is not in sorted way. So what I have to do, I have to the sort way, sort the result, and I can see the which has the most correlation. I can see that the RAM has most uh, correlation value, or we can say the score with the price range. So I will keep the top 10. If you want, you can keep anyway. Top 10 doesn't mean index 0 1 to 3. It's return this 10 value, first 10 value. So here I keep the top 10 value, so that you can easily match that the Wi-Fi is not in the list, or the 3 dual sim you cannot find the 3. So in the value, okay, now for the simplicity I use the logistic regression, as it is classification model. I just simply use the classification model, that what is the output, and here, so logistic regression. So and then we can calculate the score. So what's going on? Reach limit. Okay, I iter checkpoint result. Okay, so don't worry about that. If I give the factory reset and run it all the cell again, and I will see that the result what is on. Don't worry. Okay, so what I have say here, that it returns that I do not use here the selected features, I use all features, and it returned me the score is 96 point something. So if here I am trying to use the top 10, so the top 10 score is respectively we can see here. So I calculate the mean, and what I have to do, I am run this model. Simply I run this model here, x top 10 cross validation result, so 97. So I found 96 without the feature selection, means feature selection. I found the 0.96, and after using the feature selection I got 97. So at least 1% it increase. Okay, so now back on to our the PCA again. So as we already told you that PCA is dimensional reduction technique, so it is a feature extraction. PCA, in we can see in the earlier that feature selection, what does it mean? Feature selection means we can discard some features, but what help in the feature extraction, we can add others feature, like it if we give that a b c, it can be a b, but we cannot surely told that a multiply b or a sum of b. We cannot clearly say that it can be combination of three. So feature extraction means we can uh, generate other features, exist features. So what we'll do, you have a question come in your mind that earlier we use feature selection, that I can reduce the features model performance. Here I am raising the features, so will it valid for me? Well, so for example, if I have marks, I can easily visualize it, or this is the line, or you have a scatter plot, we can easily describe. But what if I have more than 50 dimensional, can you visualize it? I can't, but if you can, you know me, that you can visualize it. So that's why using the PCA, for example, we want to convert 52 into 2D, as we can easily view it. So that is the goal of feature extraction. Okay, so we have to see and another code of, like, it will be a error. No worry, I give the restart session. So first time it's happening for this problem, probably not, I can say that. So wait a minute. So here what I have to do, I have not used any data, I am using the some baby data. So I load the Irish data set through the Seaborn, and here we can see that the dataset result. So our target is feature extraction. I see that there is a setosa, virginica, and color. So what I have to here do, I have, this is the features, and our output is series which one is exist. So well, in X we include all the features, and in Y we also include the species. And before we uh, train the model, we have to standard or transform normalization to do this. So after applying the transformation, we will find the value. So don't worry, this is the completely one array, one row, second row, third row, this represent. So no worry about that. And here if we want to see the final data set, what it look like. Okay, so here you can see that this is the principal component 1 and PC2. So what we have to select, if we want to select the PC1 and PC2, based on which one has the majority. If we draw the line here, we can see